I'd like to say this is science, but now I'm just messing around. What's up everyone, Chris here, and today it's basically just the results of some testing that I've been doing. Now, this all starts with Stefan over at CNC Kitchen. Stefan makes awesome videos, but this one in particular, he did a bunch of tests on how different surfaces affect your 3D printer, and he did some with a concrete slab, he did them on springs, just regular hard foam, and I've always wanted to test this process to see how it affected my 3D prints. And it's probably worth your time just trying one of these concrete pavers like Stefan shows in the video, because it's going to solve a couple of different issues for a very low cost. Now, Stefan really focused on the noise aspect of your 3D printer and this mod. Now, you're taking this concrete slab, putting some foam underneath it, and it separates the printer from the surface that you have the printer on. And it does greatly reduce the noise. But there's another issue that this could solve by doing that separation, and that affects your print quality. And it's what we call ringing or ghosting. And I think that effect is actually just a little bit easier to see when I show it in a photo. Also, I can kind of point to it. But you can see these different artifacts on the letters. This is the same test print that Stefan used in his test, but you can see the echoing of this T. You can see it on all of the letters. Pay attention to the different S's right in here, even in the arms of the Y and out here to the right. When we say things like ringing, this is the effect that we're talking about and the one that I'm trying to solve today. Now, there's several things on your 3D printer that can cause this, but basically the root cause is always going to be resonance. As your 3D printer moves around, you're going to change directions, that's going to introduce vibration, and it's going to show up in your print quality. There's a couple of ways you can combat this. One, you could just slow the print speed down. That should help greatly. You can reduce the mass of your carriages, your bed and your print head. If you brought the weight down, that would lessen inertia. You could also move to a different style of printer. When the print head moves and the bed does not, that can help you out greatly. You can also go super high tech and use something like Input Shaper to fix it in the software. But today, I just wanted to test the most simple methods by separating the printer from the surface that you're printing on. In effect, all of these solutions will work as damping so that we can reduce that resonance caused by the print movement. Now, those were a lot of words, but basically I just wanted to test a bunch of different things, including that concrete block to see how it would affect just the bare table that I use mostly for my 3D printing tests. So now we did a whole bunch of testing. So here's our testing scenarios. Here's the baseline. We just took a print directly from off the top of the table. This table is 3/4 inch MDF with some snap together wooden flooring on top. Just using the noise of the printer as a gauge, you can definitely tell when you set it down on top of the table that it does magnify it a bit. So I expect the bare tabletop to be a lot worse than when we try to separate it with our different surfaces. I also wanted to try one of these. It's a fake paver stone I found at the hardware store. It's made out of old tires. They're only about $5, but it's pretty thick. I thought it might make a nice alternative to that paver stone because it's a lot easier to handle. One thing I was concerned about is that it might smell really bad, but it doesn't. I thought it'd smell like Firestone in here, but it did okay, so I wanted to try that out. And then we have the paver stone set up. I just got a couple of strips of foam. This is pretty dense foam. It's 12 millimeters thick, but I just laid 2 down and set the paver on top of that, and the printer rides on it very nicely. So we'll test that. I also wanted to test the print shelf that I print on the most. It is also 3/4 MDF, but I have a sheet of foam insulation, the kind they use on the outside of houses. It's 15 millimeters thick, and then just some very cheap carpet mat on top of that. It does deaden the noise quite a bit, but I wanted to test the print quality as well. So those are the first couple of things that I wanted to try. And I know usually I would throw a time lapse in here of me testing this, but I didn't want to bore you. I wanted to get straight to the results. But don't worry, I further complicate this whole subject in just a few minutes. But let's take a look at a few prints. A couple of notes on how I sliced this part for these tests. All these tests were done with the same filament. with the same slicer settings. This is Prusa Slicer. I'm using the 0.2mm layer height speed profile. This part was done by Stefan over at CNC Kitchen. I printed it in this orientation. Test Y along the Y-axis, test X on the back. We're going to be mainly focused on test Y because this is a bed slinger and the bed has a lot of inertia when it moves, so Y, by all rights, should be worse than X. If you would like to take a look at the speed settings for this profile, they are right here. Remember, this is PLA, you're using auto cooling. This is just the print speed that was requested, not necessarily the one that it printed at. So keep all that in mind. So here's our first print. I'm just going to stack these up so that you can see them all together. This is just the bare table, and you can see that echoing right in here. It's pretty bad, but you can see it all across the front of that test part. Remember, the ringing for these tests is mainly what we're focused on. Next, I moved to the rubber tile. It actually did a really nice job taking out a lot of the ringing. It's much cleaner than just the stock table. I was pretty impressed with this, especially for $5. They're really easy to handle as well. Then we moved to the printer shelf test. You can see this one is even cleaner. You can really see it down here on the corner. Remember, this is that 15mm house insulation foam with the carpet on it. But it really deadens the artifacts. And I'm glad to see this because I do a lot of printing on there. I'm glad the method that I was using kept it fairly clean. And let's see if we can get one more on here. And here's our paver test with the white foam underneath. It is very clean. We have a few artifacts in here. That's probably more related to filament or something happening in the extrusion system, not the echoing that we're looking at, so you can pretty much disregard that. But take a look at that corner where that ringing is. The print shelf actually performed just a little bit better. But it's still a quality print. Some less dense foam underneath would probably help greatly. You can see that in Stefan's testing. Definitely go check out his video, by the way. I'll leave a link in the description. But out of all of them that I test, the print shelf is definitely the winner. But I do kind of like that rubber tile. Anything's better than this bare table. So the paver with the foam underneath definitely helped out, and I never doubted it for a minute. Stefan does great work. But it is a little bit hard to handle, and if you had one of these for every one of your printers, you'd have to have a pretty stable surface to put them all on. But I couldn't leave well enough alone. So I have personally printed on tables that moved around while the printer moved. That's not the best scenario. But I always thought, what if you had a movable print surface that you put your printer on? It would move to counteract some of the movements of the printer and maybe take some of that vibration out of the frame by giving it a more flexible surface to print on. So I had to figure out how to set that up, and the first thing I thought of was ball bearings. But ball bearings are kind of expensive. So then I went and found an alternative. So I went online and I found these glorious orange marbles. Now, they're very inexpensive compared to ball bearings. They're really cool, and for some reason I just really like marbles. But fun fact, I found these, and the company that manufactures these marbles is only 45 minutes from my house. So I picked up 100 of these. It was just a no-brainer. These are 1-inch marbles. So then I had to figure out a contraption where I could separate the printer from the table, but allow that surface to move on top of those marbles. And my first idea was to just cut a couple of pieces of wood and connect them with a piece of inner tube that I had laying around, and then put the marbles in the middle. So this would allow you to move side to side, front and back. The printer moved, but the base wouldn't. It would just move on top of those marbles. It was very over-constrained and didn't work very well. And I think I was trying just a little bit too hard at this point. So I had to simplify it. Also, insert lost your marbles joke here. And then I made this contraption. It is an OSB floor tile. I've got some 1x2s. They would be short enough to allow the top of the marble to be exposed. And I divided it in the center because it did have a tendency for all the marbles to run to one side while I was testing. I could have used a few more marbles, but that might be in a future test. Kind of pack them in there as tight as I can, see how that affects it. So this keeps it somewhat even while it's printing. And on top, I have a plastic sheet. This is actually the base to a Railcore 3D printer. Fun fact. And all I did was hook the corners of this plastic sheet down to our floor tile with some rubber bands. And that gives us a nice shaky surface to print on. And it has kind of a cool sound. And the shaky printer table was born. Now at this point, I have no idea if this is going to help or hurt my 3D prints, or really a lot of the science behind it, why it might be effective or why not. But I just wanted to try it out. So let's take it to the montage, but I do warn you, if you get seasick easily, this is not the video for you. Let's check it out. And here's the results from the shaky table test. Remember, this is our bare table print. You can see the ringing. This one in the center, that's the one with the paver, with that white foam, the 12mm dense foam. And then the top one is the shaky table. If you look at them really closely, the shaky table didn't necessarily help, but it did change it somewhat. It did make things better in the arms of the Y and around the T, compared to just the bare table. But you can see on the bare table the different S's in here that were echoed. They're just really far apart up here on the shaky table. And the ringing that you see here in the corner, it's just a lot more dense. So the shaky table moving while the printer moved didn't necessarily help, but it did try to combat it. You can see the table moving in the part. Still better than a table that will amplify that effect, but not as good as properly damping it with something like this paver, completely separating it from that surface. And here's a look at the X results. Remember, I was just mainly focused on Y because of that movable bed. X really isn't different enough between any of the surfaces to call one better than the other. Again, table, stock, paver, shaky table. And because I found the shaky table fascinating, I couldn't just stop at this one test part. I had to at least run one benchy. I wanted to test a taller object to see if it changed as the part height increased, and a couple of other tests. So let's take a look at those real quick. Here's our row of benchies. Ringing on the benchy is usually most noticeable up here in the front corner. We have our stock table, our paver, and then our shaky table down here. The paver definitely wins. Pay attention to that porthole there. Again, the shaky table changed it quite a bit. An improvement over the stock table, I would say, but not a whole lot. Just a little bit different. The ringing is still there. Paver definitely won. And then I wanted to do a taller print in vase mode just to see if it would change it at all on the shaky table the higher it goes. So here's the bottom of those two prints when they started out. Again, this is vase mode. But let's take a look at the one that was printed just on the table. It's very typical to see on cylinders this pattern, that vertical artifact. Because we're not actually doing a circle here, right? We're not printing arcs, G2s, G3s. It's a straight line being made to go around into a circle. And it's very common to see these. Also note this part in general. It has a very matte finish. Again, we're just focused on the bottom for now. And then the shaky table part. You can see those vertical artifacts are still there. There's one. But they're very spread out. It's really hard to see in the camera, but they're actually about twice as far apart. And because of that, it actually caused the part to be a little shinier looking. Get a little further away so you can see some of that. It did change the outside of the part quite a bit. And then if we look at the top of the prints, the quality is pretty much the same the higher it went, but I think the bare table, the extrusion is more consistent. If you look at it at an angle, these layer lines over here on the stock table part meet up quite a bit better than the ones over here on the shaky table. And that's probably to be expected with that printer moving around like that. But a pretty interesting result overall. So shaky table 3D printing, the next big thing? No. But it was a lot of fun to test to see how it changed the print quality. The paver is probably still the best way to go, but I'm pretty satisfied with the stock print shelf that I used. It did a really nice job, and I don't have to mess with those pavers. So test it yourself, look at a couple of different things, see what works best for your printer. Now, I do think we could go a little further with this shaky table design. I'd like to change up some of the rubber bands with different things to change the damping, maybe try something different than marbles. I don't know, but it is a lot of fun to test this thing again, so I might continue and see what we end up with. Take care, everybody. Hopefully you found this at least a little entertaining, and I'll see you really soon on the next one.